Nishan sir,
Yep.
hello. Yes, can we
Yes,
start?
yes.
Okay. Good afternoon to respected faculty members and our head of the department, Harish Sutar sir, and also students. Myself, Parthiv Bhau, and I am currently working as an assistant professor in Parul Institute of Technology in EC department. It is my pleasure to welcome the guest speaker of today, Mr. Nishan Sonawala sir. Let me give you a brief introduction to Mr. Nishan Sonawala sir. Mr. Nishan Sonawala sir is a director and founder of Sonawala Integrated Circuit Industries Private Limited. He is software and hardware firmware developer, having all over 4 years of experience at the industrial domain. He has done his masters in VLSI design and technology and embedded system from Parul University itself in 2017. Following are his area of expertise. His area of expertise in embedded product development, controller processor, firmware development, PCB design and manufacturing. He is also working in API and SQL domain. He is currently also working in on some of the projects in Amul, HP, GSRTC, Arc Enterprise, and some other companies as well. So now I am requesting the audience to please note down my email ID and WhatsApp number for your questions. If you are having any questions in the session, then you can message me on my WhatsApp number. So I'll wait here for 2 more minutes so that you can also note down the his email ID and WhatsApp number for the same. Thank you all of you. And now let me hand over today's session to Mr. Nishan Sonawala sir. Sir, you can conclude. You can start your session.
Okay. Thank you, Parthiv, sir. I'll share my presentation. Presentation is visible. Hello. Is my
Yes, sir, it
presentation
is
is visible?
visible. Yes, sir, it is visible.
Okay, okay. Okay. Thank you so much, Parthiv, sir. First of all, I would like to thank Parul University and all the faculty members who are present here. I would like to thank to Parul University for this such a wonderful webinar. So today I'm going to share an information about embedded technology and Internet of Things. So first thing comes into mind when we talk about embedded system is nothing but the controllers and the firmwares, right? So let's first define what is an embedded system. So it is a combination of hardware and software to perform a specific task, right? Let's redefine the embedded system for better understanding. An electronic system which gives capability to device or a machine to perform fully automatic and semi-automatic tasks is an embedded system, right? As I said, it's a combination of hardware and software. So we can see that in embedded system we have different kinds of hardwares like microcontrollers, microprocessors, development boards, sensors, wireless controllers, switches, keypads, displays, external memories, And on other side, software terms can be the application GUI, middleware, firmware, data structure, code security, code language, program loader, and etc. So let me give you an example with the real time. Okay. So let's consider your mobile phone is nothing but a great example of embedded system. Look at the terms. Mobile phone contains microprocessor, sensors, wireless controller, touchpad, display, speakers, microphone, Bluetooth, and many more hardwares. On the other side, mobile phone contains graphical user interface, hardware firmwares, middleware, structure, and data structure, many more, right? So before moving ahead, I want to clear few terms like what is middleware and what is firmware and applications. So let's understand what is middleware, firmware, and applications. Firmware is a software program permanently etched into a hardware device, such a keyboard, hard drive, BIOS, right? Firmware is typically stored in the flash ROM, read-only memory of a hardware device. It can be erased and rewritten. There are levels of firmwares. The first one, low-level firmwares. This is found in ROM, read-only memory, and programmable read-only memory. Low-level firmware is often read-only memory and cannot be changed or updated. It sometimes reflects as hardware. So let me give you an example of this kind of firmware. So storage device do not need to be updated often. The memory card and the hard disk which we are using, they have the low-level firmware, right? The next is high-level firmware. This is used in flash memory for update the softwares, right? We can consider a high level firmware like ESP32 controller and the program which we are feeding inside that controller, that is nothing but a high level firmware. The third one is a subsystems. So we can consider the LCDs and CPUs are the subsystems. So these have their own fixed microcode embedded in flash drives, CPUs, and LCD unit. A subsystem is usually considered part of hardware device as well as high level firmware, right? Now let's understand the middleware. What exactly the middleware is? So middleware can be used to mean an API or library that interacts with hardware. Middleware is computer software that provides services to software applications beyond those available from the operating systems. It can be described as software glue. Middleware makes it easier for software developers to perform communication and inputs output so they can focus on the specific purpose of their application. You can consider middleware as our APIs. Let's take an example. If you have your phone and you want to use the gyroscope and the accelerometer inside your phone, so there is one middleware called an API which interacts with your software as well as your hardware so that you can get the data from your hardware on the front end of your software, right? These are the major differences between the middleware and the firmware. The another term is the coding language. As we all know that embedded C, Node-RED, Pythons are most commonly used coding languages, right? As we have seen, hardware and software terms for embedded systems. Here we have a basic architecture of embedded system. See, this is not a particular and a specific architecture, but for our better understanding, we can consider it as our embedded architecture. There is an input, there is an output. Let's take an example of washing machine. So washing machine asks you for your clothes, detergent, and the liquids, and you just have to use the interfaces like keyboard, switches, and some data you have to enter, and washing machine does rest of the things, right? So these are the best example for the embedded systems. A few examples I have mentioned here, that digital computer, digital calculator, cameras, air conditions. So these are the different types of embedded systems. Can you imagine your life without an embedded system or electronics device? common answer, in general answer is no, right? Every sector, every fields now connect with the embedded systems. We can see that consumer electronics, medical electronics, remote automation, industrial controls, automotive electronics, military, aerospace, telecom, datacom, automations. In almost every field, we have embedded technology, right? So now what will be the future of embedded system and the technology? So here I have mentioned few things about what can be the future of embedded systems. But before moving ahead, keep one thing in your mind that I want you to keep in your mind that without electronics and embedded system, every focus area described here may not get founded. So the base of every future aspects of embedded system is based on electronic systems. Without it, the mentioned areas will not possible, right? So here we have some focus areas where global leaders, technocrats, technology lovers working for the better future of mankind. By focusing on this area, we can upgrade our industries, IT sectors, government working body, medical infrastructures, pharmaceutical industries, infrastructure technology, internet technology, and many more. Many of us had heard that Internet of Things, Internet of Everything, Industry 4.0, machine learning, artificial intelligence will be the future. Yes, you have heard it right. But have you think how is it possible? What are the main key aspects of each focus area and what are the things we have to know? So let's start with Internet of Things. So let me tell you a story behind IoT. How IoT comes into picture. So Internet of Thing is not a new thing that we have heard. It's a simple internet and its communication. Okay. Traditionally, we use internet for transferring data from one end to another and vice versa. Traditionally, we use simple HTTP protocol. As we know, it works on request response type. So you can see here that there is a client and there is a server. If client wants some data from the server, then it has to send a request to the server. If it send the request to the server will identify that which client has sent me the request, and based on it, it will respond to the client, right? So the drawback of this traditional method is that it uses large bandwidth. If you are sending a small amount of text, then also it uses the maximum bandwidth. So it uses large bandwidth for smaller messages as well as larger messages. Power consumption required more with this HTTP protocol in the hardware. Another drawback is it only responds to the requested client's computer with its IP, right? So this can cause power, security, bandwidth, and many other aspects. So this HTTP protocol converts into different protocols based on the industrial requirements, the applications. We have divided the HTTP protocol into different segments, and then the Internet of Things comes into picture. For different application, we have different protocols. So here you can see that there is an MQTT protocol, XMPP, COAP, DDS, AMQP, Sigfox, Thread, Anocean, Z-Wave. There are the different protocols available for the IoT, right? Uh, I'll give you an best example. Facebook Messenger is using the MQTT protocol for its messaging services, and WhatsApp is using the XMPP protocol for its messaging services. Isn't it amazing? Right? Now let's see another thing, the machine learning at the edge. I really wanted to avoid having machine learning as a game changing trend for the upcoming decade. Machine learning is a trendy topic in this age of artificial intelligence. That fact, though, is that machine learning holds a lot of potential for embedded system developer as being a new decade. Machine learning for embedded developers, as it currently stands, has the greatest potential at the IoT age. Let me tell you one thing. When I was pursuing my bachelor's, I was amazed when a microcontroller had a clock speed above 48 megahertz with an unbelievable 128 kilobytes for flash. And now we have microcontrollers with a clock speed above 1 gigahertz with more than 4 megabytes for flash storage. These advancements are making it far easier to run machine learning interfaces on the microcontroller. Running the interference of the embedded controller at the edge opens a whole range of local application and can save and bandwidth and communication cost with the cloud. One area that seems particularly primed for machine learning at the edge in the embedded vision. Okay, so now let me give you one example. Let's understand what exactly the machine learning by the one. Uh, let's just understand with one video. I'll share one video with you. So let's see this video. The video audible? Is the video audible?
No, sir, it is not.
Wait. Now is it audible?
No, sir.
Uh, okay, let me explain the whole video. There is a machine learning terminology. So in this machine learning terminology, we have seen so far that there are different uh, types of embedded systems we have seen till now. Okay, so there is a compute calculator to the mobile. Okay, now data is being increased with this era, right? Time gets faster and faster. So what exactly the machine learning is? So here we is one example. Let's consider that we have our embedded system, and that embedded system wants to identify that this is a banana and this is a apple. Okay, so how our system will identify that this exactly the object is banana and the apple? So machine learning learns the things uh, from identifying the objects. Okay, so how is it possible? So first of all, when the machine sees the apple, it identifies its color, its property, and stored in its database. And after storing it, it will identify that yes, this is the apple. This is how it reacts. And next time when see the other things, it will definitely gives the output as an apple, right? So this is the whole video. Describe the same thing. This is an apple and this is a banana. The same machine learning terms we can use in social medias. Nowadays we are using the social medias. So in social medias, if you are searching for any products on your phone, you will be finding on browser that it will automatically populate the same advertisement which you have already searched for, right? In medical industries, organizing patients data, diagnosing the data, job applications. Yes, it is possible that with the use of machine learning, we can identify the best job applicants and remove the others, right? So this video tells that what exactly the machine learning and how, what exactly the ability of its working ability of the machine learning. Okay. The ability to perform object detection and recognition at the edge has many potential opportunities for business application and for developers to listen their workload. Okay. Next, other let's move on to another trend in firmware writing using the Python. Yes, Python is clearly the most popular programming language used by software developers outside the embedded system industry. In fact, a survey conducted last year by IEEE verified that amongst engineers, Python is the number one programming language, followed by Java and then C. One interesting information is that the Aspen Core 2019 embedded market study also found that in the last 2 years, the number of projects programmed in Python in the embedded space has doubled. So, what is it about Python that makes us think it will become a dominant language for embedded system? Yes, maybe. The compute power available in microcontroller has grown to the point where a stripped down version of a Python kernel can be ran on a microcontroller that cost only a few hundred of rupees. Second, there are already popular open source ports for Python such as MicroPython that are available in more than a dozen architecture, including popular ones like the STM32 and ESP32. Very interesting thing is that C and C++ aren't taught in most computer science and engineering programs. It now Python and some Java has been for quite some times. This means that there is and will be whole generation of engineering taking the lead in the next decade who have natural inclination to using Python. No one wants to fight with the low level hardware and the software anymore. They want their microcontroller to come running something that they can put their application specific code on quick and get their product to market. Forget worrying about register pointers and all traditional stuffs. Plus, if Python is used, anyone can help develop the product, not just using the embedded folks. So, guys, are you ready or not? Here, Python comes. Let's see the other terms related to embedded systems, safety and security, right? So we'll not discuss much details in the topic, but let me tell you what exactly the security criteria, what are the safeties, right? So let's understand the safety embedded system first. So the safety criteria application requires safe embedded system architectures with a predictable failure behavior to prevent from loss of life, substantial financial damage, or server harm to the environment. As a safe system is not likely to cause such heavy damages, there must be measures defined that intervene in case of any malfunction. The complex architecture of such system usually requires equally complex hardware, software development rules, followed by a strict certification processes. Now let's understand the secure embedded system. The security of embedded system deals with the protection of data, right? The, that they store, access to and communicate with the world, reducing vulnerability of hardware and software. High assurance embedded computing is necessary for the security, integrity, confidentiality, and high availability of the application, especially with the increasing importance of the IoT and terms like BYOD. Building protection into the device itself provides security before the corporate firewall. Security needs to be considered early in the age of design of a new system, and many even by customized according to sorry customized according to the requirement of the application, right? So this is how the embedded safety and the security terms works. There are other terms like big data management, hardware designing, prototyping, designing, and automations. I'll tell you that big data management comes in embedded system is a very vast field, right? With the use of Internet of Things, machine learnings, we are getting lots of data, millions and millions of data we are getting from different sensors, different actuators. We have to manage all the data. So we need to maintain a database system which can contains all this data, and with the use we can get the data on the front end line, right? So with this I want to conclude that the next decade has the potential to dramatically change the way that products and embedded systems are developed, right? But no matter how good you are at developing embedded systems, embedded softwares, embedded hardwares, if you don't take the time to update your skills, then within just a few years, you will find that everyone else is passing you by. You will be less efficient and find that you are struggling. So I would request you and I would suggest you during this pandemic, during this lockdown period, try to upgrade your skills and serve to the embedded community. Thank you. Now over to Parthiv sir.
Sir, there are few questions.
Yes.
At the fresher level, suppose any students want to enter in embedded system field. So which skill is
Yes.
required? Which
Okay.
skills are
So
required
first of
for
all,
a fresher? Yeah. Yes,
okay.
sir.
So yes, so when you want to enter into embedded system, first of all, you need to understand what exactly the electronics is. The very first thing you need to understand the electronics, right? The next thing is you need to learn some programming languages so that you can actually understand the flow, how to write a program for the controllers, right? The next thing you want to you need to understand the basic architecture, right? These are the few things you need to understand. But as being a fresher, if you want to start with an embedded system, you can go for the development boards like Arduino is the best platform to start with an embedded system. You will get in lots of knowledge, you will get in lots of ideas how you can build your own systems with that Arduino. So I would prefer that if you are a fresher and want to start your career in embedded system, you can go with the Arduino, as well as you need to understand the programming languages and the electronics, how exactly the electronic sensors are working, what kind of sensors you are using, and what are the inputs and what are the outputs that you need to understand, right?
Okay, sir. One more question. What is the fundamental
Yes.
difference between hardware and firmware?
Okay. So first of all, I want to say that if you want to see the difference between the hardware and a firmware, okay, so your body is nothing but a hardware, and whatever your mind is doing is a firmware. Okay, let me relate with this embedded system. So sets of instruction given by your mind to your hand or your leg perform some task, right? The same way the controller doing the things, right? Controller is a predefined architecture of the transistors. Now you have to write the logic so that transistors can take input and give you the output. The so the whatever code you are writing, right, that is the firmware for that particular hardware. So this is the major difference between hardware and a firmware. Yes,
Okay,
Parthiv
sir.
sir.
Yes, sir. There are few questions. Uh,
Yes.
regarding to the future scopes of embedded system.
Yes.
If there is a special student and he wants to know about the future scope of embedded system related to current technology, then what will be the
Okay.
scope for that?
See, as I told you that current technology is moving towards the artificial intelligence, machine learning, right? So I would suggest that if you really want to go in the embedded field with these future terms, right? So first of all, you need to understand the Python language, because Python will be the next uh, major game changing language for the embedded world, right? The next thing, you need to understand the data structure, because machine learning and the artificial intelligence is totally based on the data structures. How you are getting the data, what kind of data you are representing, right? And from the data analysis, there are different kinds of algorithms available for the machine learning and the artificial intelligence. That algorithm actually performs the different type of data analysis, and based on that data analysis, that artificial intelligence works. As we have seen in that particular video, that how you can identify that this is the banana and this is the apple. Okay, so what embedded system artificial intelligence does is it identifies the properties of that particular thing, right? And it will store inside it, and it will learn that if it has a color of red, it if it has the size of this, if it has the weight of this, then it would be an apple. This type of data analysis done with the use of some algorithms inside the machine learnings, and this is how they can identify. So this will be the next future of the embedded system. Yes, Parthiv sir.
Okay, sir. Hello.
Yes, sir.
Hello. Yes, sir.
Yes,
Sir.
sir. Yes, sir.
So, can you give just a description of essential components which are required to develop an embedded system?
Okay. So, first of all, if you want to design your embedded system, first of all, embedded system is nothing like if you think that I want to design an embedded system, it is not like that. First of all, you need some uh, specific application requirement. Okay. So, you need to understand what exactly the application requirements you have. Let me give you an example. Suppose I want to design uh, one arithmetic functions, or let's take one LED program. I want to design an LED blinking program with my embedded system. Okay, so first of all, I need to understand the what exactly the my definition is, what exactly I wanted from this embedded system. Based on that, you can identify what are the components and what are the tools you required. Okay, so the embedded system, if you want to start with the embedded system, first of all, identify your application. With that application, you need to identify how much clock speed, how much frequency it requires to execute its code sequences, right? Suppose you are choosing the microcontroller with 10 bits, or we can say that the you are choosing a controller with 20 megahertz of frequency, right? But it does not support your application requirement. Your controller requires minimum frequency, minimum cycle frequency, or frequency is minimum 51 megahertz. So the controller which you have chosen is not perfect. So the component selection based on your application is the main criteria in embedded system, right? So this is how you can identify or you can design your embedded system with the use of your application. Yes, Parthiv sir.
Okay. Yes, sir. One more question related to RTOS. So,
Yes.
so can you classify different kind of RTOS in embedded system and why it is required to use an RTOS?
See, in embedded system, let me tell you one thing, that RTOS is a real-time operating systems, right? So there are different real-time operating systems are used in embedded systems, but to classify them based on your applications and based on your working requirements is totally a different and a lengthy subject, right? But let me give you some example that RTOS, real-time operating systems, generally designed to execute the hardware level and this software level communication. We are using the RTOS. Parthiv sir,
Okay, sir. Okay, sir.
is there any
So,
question?
no, sir. There are no questions now.
Okay. If you have any question, any doubts, you can mail me on my mail ID. Right.
Okay, sir.
Over to you, Parthiv sir.
So I'm very much thankful to Nishan Sonawala sir to giving such a knowledgeable presentation, and I hope that everyone have written these contact details so that you have any question in future, then you can directly mail him. Over to you, Nishan sir.
Okay. Thank you so much, Parul University, who have given me such a chance to interact with the faculty members again, and all the viewers who have seen me and listened me regarding these embedded systems. I would appreciate. Thank you so much again, Parul University, for giving me this opportunity. Thank you so much, sir.
Thank you very much, sir.